Learning how to find a product of two functions, which is what we just did right before the end of the last video, wouldn't be very useful to us unless we could apply it to some real life problems. And hey, look here, we have a real life problem. So let n of t be the number, get it, n for number, of JetBlue passengers in millions, and f of t, which is that function, is the average round trip JetBlue fare, get it, fare, f, in dollars, both in the year that is t years since 2000. Now I have some real data here, but we don't really need this data because we were given the two equations. Now if we weren't given them, then we'd have to go find them ourselves with linear regression. But we were given them, so we don't have to worry about all that. All right, so we're going to find an equation for the product n times f by hand. So n times f, we want to find that function. The independent variable is t, right? So n was, there it is. So this is equal to 2.9, oops, I better put it in parentheses because it's the whole thing, 2.9t plus 0.5 times 6.7t plus 188.3, right? We'll deal with units as we go, but that's where we're starting off with. All right, so we need to multiply these two. This is a binomial times another binomial, so we're going to have to distribute. Be very careful with it. And this one I'm actually going to write out. I often don't, but this one I will. So it's 2.9t times 6.7t. There's your firsts, if you want to think of it in terms of FOIL. Plus, now I need my outers, 2.9t times the second item over here, which is 188.3. There's outers if you want to think of it that way. Now I need 0.5 times each of these two things. So I'm going to do 0.5 times 6.7t plus 0.5 times 188.3. All right, now you make your calculator find what 2.9 times 6.7 is. All right, so I'm going to grab my calculator. 2.9 times 6.7 makes 19.43. T squared, because you have a t times another t, that makes t squared. Plus, now I need the calculator again, 2.9 times 188.3. 546.07. 546.07 t plus, this one I can do in my head, that's 3.35 t plus, let's see, I gotta think about that, 94.15, right? Yep, 94.15. But again, if you don't believe me, you can do 0.5 times 188.3. There you go. I was right. All right, now we can combine these two in the middle. They're like terms. So let me kind of underline them so you can see it. So they're like terms. So we're going to make 19.43 t squared plus, what's that, 549.42 t plus 94.15. There we go. We have our big product function, which is what they asked us to do. All right, so part A is done. We found the function by hand. Isn't it beautiful? Now we're going to perform a unit analysis. So let me write up that function again. Actually, I'm not even going to write the function itself. I'm just going to write what it is. All right, so when we have n times f of t, that's n of t times f of t. Now remember, they wrote up for us back in the original part of the problem what each of these things was. So n was the number of passengers in millions. See that? Okay, so this is million passengers. That's the first one. You know what? Let me simplify this a little bit. Okay, so this right here is in million passengers. Okay, and then f of t is the fare that we're charging those passengers, right? So that was dollars. So dollars, right? I suppose that's bad. I'll just say dollars. Okay, so what's going to be my final unit here? Million passengers. Oh, I could say it's dollars per person, right? Because your fare is how much or per passenger, right? Your fare is how many dollars you're charged per passenger, right? So what's going to happen with passengers? It's going to go away, right? And it's going to leave you units, which is million times dollars, which is $1,000,000. Okay, so the units for that's the units for this function. So this function is in $1,000,000. Right, so there's your unit analysis. When you're looking at n times f, whatever that comes up with, its unit is going to be $1,000,000. Speaking of which, right, so let me move on from that, but does everybody get it? So n was in million passengers. Fare said it was dollars, but we kind of had to be smarter than that and go, yeah, but it's really dollars per passenger, right? Because that's, right? So I suppose I should say this, right? Even though they didn't really say it that way. It has to be, okay? And then we had to multiply them, and then the passengers disappeared because passenger over passenger divides away and leaves you with $1,000,000 as your unit, your final unit for this function. All right, so now let's go find n times f of 14. So that's where I need this part. So I want n times f of 14. Delete all this stuff. Okay, so instead of t, I'm going to have the number 14. So here I'm going to have 14. Sorry, my dog is in dream, so you might hear her boofing in the background. Hold on. All right, there we go. So then this is equal to, all right, I'll grab my calculator for this. As a matter of fact, you know what I'm going to do? I'm going to put this in because the next part has us using the calculator to do something with it anyway. So I'm just going to put the function in. 19.43x squared plus 549.42x plus, what was it? 94.15. Okay, so now I've got the equation in there, and that helps me because I can just go to the table and look at it. I mean, if you don't like the table, you can just sit there and type it all yourself. But you should get to the same number that I do right here. 11594.31. There we go. Now we got to give it units, right? So I think that's the next part. So they said, what does it mean? So we found what it was. Oopsie. Make it all one line here. And now we have to figure out what it means. So remember that 14 was t, right? So t equals 14 implies we're talking about after, let's see, 2000 was our starter year. So t equals 0 was 2000. So we're talking about t equals 14 is 2014, if I'm not mistaken. Let me go back. Yep, our starter year was 2000 right there. Okay. All right, so in 2014, JetBlue is expected, or the model expects, here, let's put it this way. The model predicts that JetBlue will make about, and this was $1 million, so 11594.31 million dollars. Oops, I already have the dollar symbol in there, in 2014. Now the weird thing is the unit on that is a little strange because it's $1 million and we're talking about 11594. You might be thinking, well, what does that look like? So if you move the decimal place over real quick, hold on. There we go. I got it in there. Okay, so what happens is the 11594, that 4 that used to be the ones place, when you say it's worth millions, it becomes the millions place. And then you have 310,000, right? In other words, you're transforming it from being the 4 was in the ones, you're moving the decimal 6 over to the right because it's millions. Millions is this decimal place right here. So you say, okay, that 4 was in the ones place and now it's in the millions place. here's your ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, see? So that's another way to write it. So if you want to write it out, that's standard decimal notation. So here, there we go, standard decimal notation. So there you go. So 2014 is the year. JetBlue should make about that much money because it's that much money per person times how many people, right? I mean, what you're doing here when you find n times f just away, you're multiplying how many passengers they're expected to have. That's your n function, times how much you're charging them. Notice the fares are going up. So you take how many people you have in millions and multiply it by how many dollars you're charging them, you're going to have how much money the company's making in $1 million, right? So I guess I could make a note of that right here. There we go. So note, that's what your function n times f is finding. It's finding the total revenue. Revenue is the money you're making for JetBlue in $1 million. And that's what this was borne out right here. Now we're going to use a graphing calculator to determine whether the function n times f is increasing, decreasing, or neither for non-negative values of t. Well, all right, that means we have to have that function put in there, which it is. Here's the function. I'm going to go to my window and I'm going to make a wise window. Now it said it wanted non-negative values of t, so I'm going to make my x min, which is my t min, start at 0. And I'm going to try going up, I don't know, 20. Let's see how it looks. Give it 20 years. I mean, we go to 14 for this problem right here, so let's go to 20. And then this is talking about revenue, and you can see that even at 14, I think I'm in the tens of thousands. So I'm going to have to go 0 to, I don't know, let's try 20,000. Let's just see. We don't know what this is going to be, but we'll find out. And then let's try 5,000 for my tick marks. That'll give me 4 tick marks altogether. Let's graph. And there you go. That's what it looks like. So we'll draw a quick sketch of that to show, right? That's how you show your work. So you draw a quick sketch of it. Now, let's answer their question. They said graph a calculator, did that. To determine whether the function n times f is increasing. Okay, so n times f of t, I guess I could make it more efficient. Well, that's right. N times f is increasing. Increasing, for sure. Okay, so hopefully we can all see that. Now, what does that mean? This means that over time, or since 2000, the money, it's called the revenue, the money JetBlue makes. So let's put it this way. JetBlue is expected to be making more and more money, right? In other words, the model predicts that JetBlue has increasing revenue. It's going up. All right, we are all done with that section. And I will see you back here for section 6.3, in which we are factoring. Yes, factoring. And that's pretty much what we do for the rest of this chapter. It's factoring, factoring, and more factoring. So I'll see you then.